yung scholarship niyo, pati ano po, yung pati accommodation, ganun po.
Actually, yung scholarship po ay ano lang, ang sagot nila is yung tuition fee pero merong monthly stipend po. And yung monthly stipend, ikaw po bahala kung paano mo siya iba-budget. Although malaki po yung monthly stipend naman, like enough for ano po. Especially for my case, since sa Nara po siya, kasi kung Tokyo, ang problem ng mga students na same na case ko, masyadong mahal yung cost of living po. Sa Nara po kasi ano siya, katabi lang siya ng Osaka pero medyo province type siya. So mas preferred ko po siya actually.
Magkano po yung living allowance niyo po, bale, per month?
Yung monthly stipend po is around 145,000 yen po.
That is equal to in pesos po?
Mga around half po mga around half. So siguro mga 70,000 pesos po siguro.
70,000. Tapos, nakatira po kayo sa, para may dorm?
May dorm po yung mismong university po.
Nice.
And mura po siya actually para dun sa university na papasukan ko. Mga asa around, siguro in pesos, mga around 5,000 pesos per month lang po siya.
Sobrang mura nun. Kasi mahal po.
Yes po.
Pinamahal sa Japan yung bahay po no?
Yes po. Sobrang mura po talaga. Actually, kung sa Osaka or kung Tokyo, kung sabihin natin Tokyo, siguro yung ibang students gumagastos ng 30,000 pesos, 30 to 40,000 pesos per month just for the accommodation po.
Nakikishare lang, no? Ng room.
Pero marami po sa mga kakilala ko na hindi solo dorm po pero ganun kalaki yung ano.
Yun kasi auntie ko po na assign sa siya yung consul general sa Tokyo. Before.
Okay po.
Tapos yun sinasabi nila, hindi ako nakapunta yung banyo, habang nakaupo ka doon sa toilet bowl, pwede ka na mag-toothbrush sabay. Ganun lang palit. Ganun palit. Pero equivalent sa pesos before, that was like 20 years ago, equivalent sa pesos, 100 plus thousand na.
Opo, may mga ganun po talaga. Actually, parang mas konti lang yung ilalaki ng space pero ang laki na nung kailangan madagdag dun sa fees po na kailangan bayaran. So minsan depende rin sa mahanap mo pong lugar, ganyan. Pero luckily naman po for my case, merong university dormitory po na pwedeng pagstayan ng student for as long as student siya. Common po kasi sa Japan universities na kapag student dormitory, pwede mo lang siyang gamitin for 6 months or 1 year and then after po nun, kailangan mo na maghanap ng sariling lilipatan to serve other incoming students po. Pero for our case po, pwede kami magstay sa university dorm basta student pa rin po kami ng university.
Malaki po yung dorm, no?
Yes, actually, po, malaki naman yung room. Enough naman po siya for one person living in the room po.
Nice. Kami yun, Josh, para may mga idea ko sa ganun yung mga mga dadaanan na po.
Ayun. So anyway po, ready na ba Joshua for today's discussion? Ready? Okay. So again, our topic is on chemical equilibrium and konting recap lang of what we discussed so far. So we looked at the chemical equilibrium state, its characteristics, and kung ano yung changes na nangyayari, including the rate of the reactions. Okay, so always remember lang, equilibrium, it is a dynamic process in which both the forward and the backward reactions are happening simultaneously at the same rate. Okay, and also remember that an equilibrium condition can be established for a closed system. So once you open the system, may lumalabas na from the system or may pumapasok to the system that will cause a disturbance dun sa equilibrium condition. Okay? And later in this topic, i-discuss natin yung effect sa equilibrium position depende sa kung anong klaseng stress yung in-apply. Okay? We'll look at the equilibrium constant expression. Just remember, this is just a mathematical expression relating the ratio of the concentrations of the product over the reactant in their equilibrium state, all raised to their respective stoichiometric coefficients. Okay, so always make sure to balance the equation when writing down the equilibrium constant expression. Okay. And then we also looked at Kp values, Kp expression. This is just the same as Kc, but the value is calculated using pressure values, specifically expressed in ATM, okay, in atmosphere.
Opo.
And we also looked at heterogeneous equilibrium. Always remember lang na when writing down equilibrium constant expression, never include pure solids or pure liquids in the expression. Okay? Pero physically, they take part in the reaction, but in the mathematical expression, hindi. Okay? Yun lang. And then for multiple equilibriums, parang yung approach natin dito is pretty much the same with how we do Hess's law. So we consider several reactions, tapos tinitignan natin siya, or we manipulate the equations, and titingnan natin kung paano tayo magka-come up with a certain chemical equation. And then from the different manipulations that we did, yun yung merong corresponding change sa equilibrium constant expression. Okay? And then yung magiging total ay equal lang sa products ng mga individual equilibrium constant expressions. Okay?
Opo.
Okay. And then also we all will look at how we interpret the values for the equilibrium constants. So always remember, equilibrium constant is a positive number. We can never have negative value for equilibrium constant. And the value, whether it is greater than 1 or less than 1, it tells us something about the equilibrium position. Okay? So kapag greater than 1, the equilibrium favors, or the equilibrium mixture predominantly are the products. Okay? If the equilibrium constant is less than 1, then the equilibrium mixture predominantly are the reactants. Okay? And then we also have a way of predicting the direction of the reaction. Starting from the initial condition, we can predict whether the reaction would proceed from left to right depending on the relationship of the reaction quotient Q and the equilibrium constant K. Okay? So this graph here shows how we can compare the values of Q and K to predict the direction of the reaction. Okay? Now, this is the part where we ended our last meeting's discussion. Tama? Tapos nasagutan na rin natin itong practice exercise na to, di ba?
Opo.
Okay. Now, at this point, we will be doing calculations of the equilibrium concentration. Okay? So look at the general equation here. We have AA plus BB forming DD and DE, where these lowercase values are the stoichiometric coefficient and the uppercase letters are our representation for the chemical reaction, for the chemical species. Okay, so we have the products D and E and the reactants A and B. Okay, familiar ka with ice table? Okay, so in equilibrium, there is what we call ice table. This is actually very important. Okay, and diba, for the equilibrium process, yung extent ng reaction is not 100%. Okay? Meaning not all the reactants gets converted into the products. May certain extent lang. Okay? Na na kapag na-reach na nila yung equilibrium concentration, yun na yung magiging constant na concentration nila. Tama?
Opo.
Okay. Now, to keep track of the changes in concentration, we construct the ice table. So for the ice table, you just have to list down all the reacting chemical species. So A, B, D, and E. Okay? And then you also have to list down their initial concentrations, the change in their concentration, and their equilibrium concentrations. Okay? So depending on the problem, pwedeng usually ang malalaman natin una ay yung initial concentrations. So you're right here, the initial concentrations. Okay? And then there will be a change, okay, in concentration. By convention, we put negative for the reactants and positive for the products. Kasi ang idea natin dito, titignan natin na yung direction ng reaction is from the reactants to the products. So when reactants react to form the product, nababawasan yung amount nila. Tama? And yung amount na nababawas, hindi natin alam kung gaano kadami. So we can just express it as a variable x. Okay? Now, to consider the stoichiometry, for every AX amount of A na nababawas sa kanya, ganun din dapat yung merong equivalent na BX amount na nababawas kay B. Tama? And at the same...
Ang products po, positive, no? Ang reactants.
Yes. Yes po. Bali, by convention, ang tingin natin dito is for every AX amount of A that reacts with BX amount of B, we produce DX amount of D and EX amount of E.
Is it possible po for somehow na may isa pong reactant is nababawas po, isa naman reactant, tumadagdag po, tapos hindi sa kabala naman po na products, tumataas yung isa pero bumababa yung isa?
Okay. For this case, always remember equilibrium is a closed system. Okay? So the reaction you are looking at is the only reaction happening. Okay? Unless merong ibang reaction. Pero kapag merong ibang reaction, that's a completely different case. Okay? So ang titignan lang natin dito ay equilibrium reactions na nangyayari as an independent reaction. Okay? So isang way lang ang pwedeng mangyari. Tama? Kung reactants, kung ang direction ng reaction natin pag ganito, then A and B will react to produce D and E. Or is your question, ang tinutukoy mo ba is what if ganito yung direction ng reaction?
Hindi po, tinutukoy ko po if it is possible for, kumbaga po, there's sort of a mixed reaction where on the reactant sides, one of them is being produced and the other one's being reduced. While yung sa product side naman po ganun din.
Hindi. For that case, hindi. Okay? I mean, sa case na to na pinag-aaralan natin, hindi muna. Okay? We will be only looking at a reaction na exclusively nangyayari dun sa system. Okay? So kung merong ibang reaction pa na nangyayari, that would also cause a disturbance in the equilibrium. Okay, so ibang consideration din yun. Okay, so for now, ang gusto lang muna nating makita ay isang closed system reaction. Okay? So dahil closed system, walang effect, walang any other effect from let's say a reacting species coming from the surroundings, hindi natin i-consider yon. So nakatingin lang tayo muna sa isang reaction na closed system reaction. Okay? Okay. So yung isa naman, pwede rin actually na ang direction ng reaction ay ganito. Depende sa Q and K. Tama? Pero by convention, para lang consistent tayo with how we do the calculation, we always put negative change for the reactants and then positive change for the products. Okay? Pero later on, when we do calculation, maybe you will see some more examples on how we can interpret the values. Okay?
Opo.
So now, if we observe a change in concentration of excuse me, of reactant A, but at equilibrium, we expect its concentration to be just equal to C sub A minus AX. Okay? And for the B, that's C sub B minus BX. And then D is C sub B plus DX. And then for the E, for the E product, C sub E plus BX. Okay?
Opo.
Now, the equilibrium expression or the equilibrium concentrations can be calculated by primarily solving for X using the equilibrium expression. So Kc is equal to, always remember, it's the product over the reactant. By the way, sorry, actually, na-realize ko may mali dito sa expression. This should be raised to D, E, A, and B. Okay, so substituting, this should be raised to D, E, A. Sorry, hindi ko siya na double check.
Opo.
Paano na lang
Do you know po which ones technically, if let's say po the reactants and products were introduced at the exact same quantity, an exact same relative quantity, tsaka yung ano po. Which one is the reactant and which is the product if you are not given the chemical equation?
Okay. Actually, for that case, you can consider one direction. Okay? Kahit na ang i-consider mo is yung from AB to DE or DE to AB, okay lang. Okay? And mas makikita mo siya later on when we do the problem solving. Okay? Kasi later on, you will see na when we solve for the value of X, lalabas na isa lang yung pwedeng maging direction. Okay?
Opo.
So let's now eto. Actually yun lang talaga yung sa discussion na part. Most of the thing we'll do here are problem solving. Okay? So let's start at this practice exercise number 8. Okay? So for the reaction Br2 forming 2Br, so this is just the dissociation process of bromine gas. Kc is equal to 1.1 times 10 raised to negative 3. This is at 1550 Kelvin.
Kaya pala po
Okay.
nag-dissociate ng bromine.
Yes. Well, for this case, we are looking at the reaction at 1,550 Kelvin. Okay. So if the initial concentrations are 0.063 molar for the bromine gas and 0.012 molar for bromine atom, calculate the equilibrium concentrations of these species. Okay. So first, wait a moment. Mag-add lang ako ng blank slide.
What if po, I will just share a whiteboard.
Actually, sige. Hindi, actually, gusto ko kasing kopyahin yung question, pero hindi ko siya ganito lang sa akin.
Screen yun.
Sorry. No, mali ako nang nakopya. Para meron tayong copy ng question.
Ano po yan? Screenshot or ano po? Talagang part po ng PowerPoint.
Actually, yung original na PowerPoint ko nito ay na-corrupt. Pero meron akong saved PDF. So, in-export ko lang siya as image per slides from PDF.
Image pa per slides. I've been deceived. Kaya pala po hindi na po ma-edit yung may A, B, D, E po.
Sorry. Pero kasi na-corrupt yung yung original file. Ang hirap pa naman gawin ng slides. Anyway, so for the reaction Br2 yielding 2Br, this is how we do it. First, actually when you solve for equilibrium type of reaction, always start by writing down the equilibrium reaction. So for this case, let's just follow how it is written. Br2 forming 2Br. Okay? And the Kc value for this reaction is 1.1 times 10 raised to negative 3. Okay? And then after writing down the reaction, you need to construct the ice table. So what are their initial concentrations? For Br2, initially it is 0.063. Okay? For Br, this is equal to 0.012. Okay? And by the way, Joshua, whenever you write down or whenever you construct the ice table, always remember na whenever you fill it out, make sure that the concentrations are expressed in molarity. Okay? Never fill in here weight values or volume values or any other concentrations that are not expressed in molarity. Okay? Laging molar concentrations lang siya dapat. And not even number of moles unless the total volume is 1 liter. Okay?
Kung total volume nga po, kasi po yung molarities, din pala yung definition, kaya pala.
Yes. Kung total volume is 1 liter, then the number of moles is numerically equivalent to the molarity. Okay? Now, for the change in concentration, now we start the reaction with both of the reactant and the product present. Okay? So actually, we still, if you want to know the direction, if you really want to know the direction of the reaction, you need to solve for Q and then compare it to Kc. Tama? Para malaman mo if the direction will actually proceed from left to right or from right to left. Pero there's really no need for that. We can just stick with the conventional way of solving equilibrium reaction. And then the math later on will tell you kung ano yung tamang direction. Okay? So for this case, let's just follow the stoichiometry. If the reaction proceeds from left to right, then there should be a minus X amount in the concentration of Br2. Okay? And for every X amount of Br2 dissociating, there should be a plus 2X amount of Br being produced. Tama? Does that make sense? Okay. Now, at equilibrium, we expect their concentrations to be 0.063 minus X and 0.012 plus 2X. Clear? Okay. So, since we now have our expressions for their concentrations at equilibrium, we can actually substitute this to our Kc expression. And our Kc expression is properly written as Br squared product over reactant Br2 raised to 1. Tama? Now, whenever you see the bracket symbol, it always refers to equilibrium concentration.
Opo.
Okay? So, for this case,
Oh no, I
we can
see.
actually... Nakita mo na?
Talagang pa yun, pa-closer and closer to full mathematics.
Yes,
Nakita ko na po ang quadratics.
Pero actually, sabihin ko lang din na for equilibrium, most of the time, we will be dealing with quadratic equations. Okay? Pero I think, you're okay with using your calculators naman, di ba?
Me when it doesn't go over quartic. Yes, the calculator can solve.
Pero I think sa mga examples, hanggang quadratic lang naman. Okay? So for this case, we have, this is our expression for the equilibrium concentration of bromine atom. So this becomes 0.012 plus 2x squared over 0.063 minus x. Okay?
Opo.
Okay. And this equation here is equal to the Kc value. Okay? This Kc value are experimental values. It's an experimental value. Okay?
Opo.
So,
Mathematics.
we can rewrite this equation into, so ano lang natin, i-multiply lang natin to with itself. So, sorry, wait lang. Kunin ko pala yung calculator ko.
1.44 times 10 to the negative 4 na ano po yun.
Yes. So 12 times 12 is 144.
100 times 100. 1 million.
So 12 times 12. Oops, nasa yung cursor ko. So this is 1.44 times 10 raised to negative 4. Plus 2 times 12, 24, 0.024x plus 4x squared. Okay? Over 0.063 minus x. And this is equal to 1.1 times 10 raised to negative 3. Okay? So yun, let's just let's just do further manipulation. So ilipat lang natin to sa kabilang side. 0.063 times 1.1 times 10 raised to negative 3.
Sa lab po, umabot ba kayo po ng quartic?
No, even for undergrad level na discussion, walang ganong walang ganon. And medyo bihira din naman siya, especially for common reactions. Medyo bihira naman yung ganong klaseng case. Okay. And actually for that case, medyo advisable na lang din if you use some other calculation methods involving advanced software, for example. Okay. Pero for undergrad cases, ano lang hanggang quadratic equations lang din.
Opo.
Plus 0.024x plus 4x squared. This is 6.93 times 10 raised to negative 5 minus 1.1 times 10 raised to negative 3x. And then, i-write lang natin siya into 4x squared. Yung x term natin is 0.024 plus 1.1 times 10 raised to negative 3. So this is plus 0.0251x. Sorry, dapat yata tama. 0.024 plus 1.1.
1.44 times 10 to the negative 4. Ay, minus 6.93 times to the negative 5. 7.47 na?
So
Wait
plus 7.47
Ayun po, times 10 to the
times 10 raised to negative 5. This is equal to 0. Okay? So we have our quadratic equation here. And for the quadratic equation, we should be able to get two values of x.
Wait a minute
And
po.
what?
Lumalabas po sa calculator is there's a complex something. There's a complex part po. There's an imaginary part sa root po.
Okay. So ano ibig sabihin nun?
There is it's impossible.
Nasolve mo na ba yung values ng x?
Opo, it's like meron po siyang plus hanggang parma 3 to the negative 3i. On both of them po may plus minus. So,
Both of them, so maybe may mali sa ginawa ko. Wait lang. Dapat di dapat pareho. Okay, let's double check. 0.012 plus 2.
what if talaga pong, is there an occasion na it really ends up with a complex number? Kung yung case po na yan, what will you do?
Actually, for that case, most of the time, minsan may ganito. Even if even if you're not talking about the complex numbers, sometimes for quadratic equations we end up getting one positive value and one negative value. Okay? So sometimes yung x already represents the concentration. So yung negative value is correct mathematically, but it doesn't have any physical meaning. Okay? So
Opo.
gagamitin natin yung isang value. So that's the correct one.
Extraneous
Okay?
po. Pero what if both roots po are extraneous? Does that mean the equation does not exist?
For that case, since nakuha natin yung equation from this kind of values na physically possible naman, I think hindi dapat tayo makakuha ng values ng x na completely ay may imaginary part.
Oh no.
So, dapat
Okay.
look into the computation po baka may mali.
So pwede nating i-double check yung algebraic manipulations natin.
Oh no.
So 0.01.
Yan po. Me with the shift solve option. Tanan. Pag may lumabas pa, gagawin niyo po sa complex mode, pag may lumabas pa rin po ng complex, sasabihin, it's doomed.
Actually, let me try by inputting the equation.
Pero,
As
parang
it.
isa lang yata po yung lalabas na root pag
Pero ito rin pala, usually ang ibibigay sa'yo ni calculator na root ay hindi yung negative at hindi rin yung may imaginary number. Okay?
Ayaw niya pong solve sa complex form. No! I have to do everything again.
Ayan, may nakuha na akong value.
What?
Na walang complex part.
What happened? Oh no. I am doomed. Minus x equals 1.1 times 10 to the negative 3. Solve. Cannot solve. Tanananan. Oh no.
Ano yung type mo? Ano yung type mo na equation?
Baka may mali po ako. So, yung sa numerator po, I just typed in 1.44 times 10 to the negative 4 plus 0.024x plus 4x squared. Just as is po all over 0.063 minus x equals 1.1 times 10 to the negative 3. Lumalabas na po wait lang po.
Ito isa ding tip, Joshua. Before you do, ano yung gamit mong calculator?
Yung FX991EX po.
Okay. I-clear mo muna yung memory before you do the solver function. Clear mo muna yung memory.
Wala po siyang memory.
Walang nakastore pa.
Wala po.
Walang nakastore. Okay. Pero i-clear mo yung memory and then preferably when you write down your equation, huwag kang maglagay ng denominator. So i-type in mo siya as yung isang side ng equation, multiply mo with the other side, equals the other side times yung nasa denominator. So wag kang maglagay ng denominator. Usually mas mabilis ma-calculate ni calculator kapag ganun eh.
Okay. This is my last hope. Thanks. Moment of truth. Cannot solve!
Cannot solve? Bakit kaya? Pero meron akong, ito yung i-try mong i-type. Type mo, quantity 0.012 plus 2x and then quantity squared equals 1.1 times 10 raised to negative 3 times quantity na 0.063 minus x.
This is displaying suffering. What? May lumabas!
See? minsan kailangan mong bigyan si calculator. Actually same lang sila, kung iisipin natin, pareho lang yung expression. Pero minsan kapag sinusulat mo siya as
Kaya
a
pala po
ratio,
nalaman ko po kaya pala po may mali. Kasi po yung, di ba po, 2x po yung ano po yung sa isa, yung 2 po yung coefficient ng x. So, yung ano po, yung coefficient ng x sa naka-square na po is not just 2 times 0.012. Instead, it is 4 times 0.012.
So mali yung equation na yan.
or
Ito po kasi hindi na-include po dito.
Pag ano to?
Wait lang po. Mag-annotate lang po ako.
okay.
May ito po kasi. So, ma-multiply. We should
Kasi may plus with itself pa.
Opo,
Okay.
yun po.
Tama. Sorry.
I need to check if this will work.
Yes. Dapat. Okay. So, ganun lang din yun. Actually, minsan if you are getting that kind of value, you can double check the algebraic manipulation. So, baka may mali, ulitin lang, tapos tsaka gawin ulit. Okay? But later on, actually, you'll see na as soon as you were able to write down the equilibrium expression, you can just simply type it in your calculator. Okay? Pero ano lang din, yun nga, yung tip ko kanina, medyo bigyan mo ng format si calculator na baka mas madali niyang ma-process. Kasi definitely yung calculators natin, may program lang din naman sila. And minsan yung based sa program nila, mas nauuna yung ganitong process bago yung ganitong process. Kaya merong pagkakasulat na mas mabilis ma-solve ni calculator kaysa sa ibang pagkakasulat. Although technically pwede nating sabihin na pareho lang naman. Pero depende pa rin sa program kasi ni calculator.
Moment of truth na po.
Nakuha mo na?
Wait lang po. I need to see if this... Talagang ginawa ko na po. Pinarenthesis ko na po lahat ng mga possible na parenthesis para kung in the advent na magkamali yung calculator, patay.
Okay. So bali ito pala, nakalimutan natin, 0.012 times 2 and then times 2 pa. Kasi ipa-plus siya with itself, no?
Tama nga po ako.
Direct,
Pag-ainan ako po, pag sinasitute na po ito po, ito, by yung 0.048, makuha ko po is, dalawa sila negative. Oh no. Oh
i-ano na lang
no!
natin.
Oh no!
Actually, for this case, let's get the two numbers. Okay? Ito yung sinasabi ko sa'yo na yung numbers mismo yung magsasabi sa atin kung ano yung direction ng answer. Ay, ng equation. Okay? So, let's get both the numbers. So, let's correct lang din this part. So, this should be 0.048. And then, saan natin ito i-add? So, 0.048 plus 1.1 times 10 raised to negative. So, this should be 0.0491. Okay.
When you thought po you have saved the ship from sinking, but then they hit another iceberg.
So, gamitin ko lang yung quadratic equation function sa calculator to double check. And then 7.47 times 10 raised to negative 5. So, one value is negative 1.7793 times 10 raised to negative 3. The other value of x is negative 0.0105 x. Okay? Now, we have two values of x. Which one of this is the correct value? At this point, we have to substitute the values to our equilibrium concentrations. Okay? So, if we use x sub 1, so kunin natin tong part ng equation, let's write down E sub 1 and E sub 2. These are the equilibrium concentrations. If we use x sub 1, E sub 2 is the equilibrium concentration if we use x sub 2. So what should be the equilibrium concentration of Br2 using x sub 1?
Pero actually po, I think po, just by common sense, doesn't it make more sense kung x2 po yung ginamit na po kasi x sub 2 is closer to the current values than the x sub 1.
Let's see. So
Exab.
plus 1 point.
Kasi pag ginamit ko po yung exab man, halos negligible po yung ano eh. Yung effect.
Yung change.
And in yung sa process po, it seems na it must happen vigorously kasi nasa 1,550 Kelvin po siya.
Well, yeah, that's true. Pero sometimes may mga reaction na hindi natin ina-expect na magiging ganun yung behavior. Okay? So just to be sure or just to account all the possibilities. For at least at this point, we can look at both the numbers. Okay? And then we decide after we saw kung ano yung magiging answer. So for equation 1, this is 0.064 7.
Baka po, what if in this entire time, it turned out the correct way to write this po was actually like this. So
Actually,
it would
if
make
you notice, both of the values of x are negative. Okay?
Opo.
It only means that the direction of the reaction is not really from BR2 to BR.
Yun nga po.
Okay? The direction really is from BR to BR2. That's why sabi ko sa iyo kanina, hindi naman din ka-important kung i-consider mo ba yung from reactant to product or product to reactant side. Kasi this is an equilibrium process and both of the reaction coexist. Okay? So yung numbers, yung magsasabi sa atin kung ano yung tamang direction. Okay?
Opo.
So let's continue this part. So 0.012 plus 2 times negative 1.7793 times 10 raised to negative 3. This becomes 8.4414 times 10 raised to negative 3. Now, if we use x sub 2 value, 0.063 plus 0.0105, this is 0.0735. And then 0.012 plus 2 times negative 0.0105. This is negative 9 times 10 raised to negative 3. Okay? Now, how do you interpret the values?
For yung E1 po, it looks like yung ano po, the BR2 negligibly changed, but the 2BR for some reason is very very low. Hindi naman po actually, it's just it moved by mga 4 from its current po na 0.012 naging 0.008. So
Yes.
this naman. Pero yung
Okay,
BR
pero actually sa numbers na to, merong isang striking na detail. Look
Yun
at
nga po.
if we use x sub 2, the concentration of BR becomes negative. Okay? Now, while this number is mathematically correct, it doesn't have the correct physical significance. Okay?
I was wrong.
Kasi it will give us, kasi if we use this value, it would mean that the equilibrium of concentration of Br atom should be negative. And the negative concentration has no physical meaning. Okay? Hindi pwedeng maging negative ang concentration value. 0, pwede, it means wala siya. Positive means meron siya at some level. Okay? But negative, would it mean na may utang tayo sa equation? Or may utang tayo dun sa reaction mixture? Hindi. Okay? So again, this is correct. This is a correct number mathematically. Pero if we substitute the value, the acceptable values for the equilibrium concentration should be these values.
Ito po yung talaga pong ito po pag in-interpret na po yung extraneous root magkakaroon ng aksidente.
Okay. So far, okay?
Abo.
Clear ba?
Abo.
Okay. Actually, another practice. If we solve for QC, ano yung value ng QC ng reaction?
BR2. BR, I accidentally changed the settings. Ano po yung current? 1.1.
So 2.28
2.28 times 10 to the negative 3.
times 10 raised to negative 3. So which one is higher? QC
UC is higher.
higher. Meaning the direction would actually proceed from right to left. Okay, which is consistent with our answers for the equilibrium concentration. Clear?
Opo.
So therefore, for this problem, the final equilibrium concentration of Br2 and Br are 0.0647 molar and 8.44 times 10 raised to negative 3 molar.
Wala na po ako
Is this
malagyan
clear?
Opo, wala na po ako malagyan na spot na hindi na po natatakpan ng pag yung annotation bar po tong text no. Hindi ko na.
Sandali, copy ko na po.
Gagawin ko na po parang sa Samsung TV nagbo-bounce para kita-kita lahat.
But anyway, is this clear? Do you have any question for this problem? Okay.
Just,
Now,
pwede pong balik. Sorry, malapit na
yes
po.
po. Ano po?
Kinokopya ko lang po.
Sige po.
Okay po sir, tapos na po.
Yay!
Okay.
Finally.
Now, let's look at problem number 9.
Oh no. Sira. Yun.
Wait lang, tingnan ko muna kung anong mas magandang sagutan. Kung 10 na ba or... hindi. Sige, let's look at question number 9 first. Okay?
Screenshot. Oh no. It's the screenshot function. Yun na!
Actually, hindi naman siya screenshot kasi I used a software para i-extract yung
Ano po
bawat
software po
PDF file. Meron akong ginagamit, Nitro Pro PDF. Pwedeng i-extract yung yung content ng PDF. So, binigay niya lang sa akin siya sa compilation of pictures. Now, let's look at question number 9. So, for a mixture of 0.5 mole, take note, number of moles of H2 and 0.5 mole I2 was placed in a 1 liter stainless steel flask at 430 degrees Celsius. So the equilibrium constant for the reaction is 54.3 at this temperature. So calculate the concentrations at equilibrium of all the chemical species involved.
Oh no, it's
Okay.
now it's me who has to solve. Okay.
Yes.
Okay, mixture of then place in a H. I'm just following basic instinct. Yes, wait. What?
Yeah, good. That's good pala. Sorry. Actually, may mali akong example na pinakitahan yun eh. Whenever you write down equations, always write down the state of the chemical species. Especially if it's gas, liquid, or solid. Kasi it will serve as a reminder. Di ba remember, if it's a pure liquid or a pure solid, they don't take part in the equilibrium expression. Okay?
I wrote down I2 gas. So apparently
Yes, tama yan. This is gas.
Wait,
This is I2 gas. Kasi ang pagkaka-state nito ay the equilibrium constant for the reaction. So specified na mismo yung reaction. And also if you'll notice, the total, the temperature of the system is 430 degrees Celsius. Okay?
Pero kung
So at that temperature, we expect iodine to be gaseous. Okay?
Inano po ba, ini-express po ba ang plasma as a state or something?
For that case, parang ibang klaseng reaction na siya. Kasi 'di ba plasma involves yung
Ionized.
electron, yung
Ma-ion.
ejected na electron. Ionized lang naman siya, 'di ba?
Opo.
So hindi na siya covered ng simple chemical equilibrium.
Tsaka is plasma technically even a state if they're just literally different particles already?
Well, ang ano lang naman diyan, ang idea lang naman diyan is they behave differently. So they consider that a different state.
Suspicious.
Actually, lalo sa particle physics, hindi ako masyadong maalam doon sa part na yun. Pero sa particle physics, sobrang dami ng state of matter.
Pero po, muntik po ako maloko. Wala. Alam ko na. Ay,
Yan, be careful din sa mga
Tapos
ganyan
nito po,
parts.
naka-Celsius, dapat naka-Kelvin. Nahanap ko lahat. Ay, yung periodic table, wala pala sa akin. Oh. Sulkan na pala lang kailangan ko. Ayan. Yes. Wait. Do I even need the periodic table? What am I doing? I don't know anything I'm doing. I forgot po it was not in grams and I did not need the molar pack.
Yes. And actually, yung total volume is also 1 liter.
No.
Okay.
What? I was on the brink of ano po. This is literally torture. It turns out that I was using the correct values. Unknown.
Yung PDF converter po, free po yun.
Hindi po.
May bayad, kaya pala.
Magkano po? Ala. Nag-invest po kayo kasi
Ay,
nag-correct.
actually, hindi. Yung kuya ko yung yung may maraming sa mga softwares po. Nakikigamit lang po. Kasi yung kuya ko mas po siya, mas techie po siya.
H2. What am I doing? Okay.
Joshua, before you proceed, I have a comment. For this, based on how it is stated, the equilibrium mixture only contains H2 and I2. Okay?
Oh.
Okay.
I don't
So
need the
initially, part ng product ng reaction, so it should be still written in the ice table, important yan. But kapag for that case, if hindi siya nag-exist, so you put 0. So initially, wala siya. So it's 0.
Bro,
Okay?
I realized.
Yes. And actually, for that case, and 0 yan, isa lang yung possible na direction ng reaction. Okay?
So, all of that time po na pinagdulutan ko po straighten out yung line na yun. Pero po, kung kahit na pa ganun, at pag nag-generate na pong HI, babalik naman po siya eh. So, technically, it should be... At kasi po, parang siguro sa yung derivative po kasi parang isabihin po yung instantaneous rate. So, at the very instant po HI is formed, it's also the same instant HI turns into H2 and I2. So, therefore, technically, it's already in a reverse mode din.
Parang ganito yung may itsura ng graph. Hindi ko, parang ganyan. So there's no way na na yung value ni I and H2 maging mas mataas compared sa kung saan sila nag-start. it should always be lower. Kung sakaling 0 si HI. So yung only possible path lang is for the equilibrium concentration of H2 and I2 to be less compared to their original amount.
Is it possible po
Tama?
na pag ano to po, ito po ay pag ganun, tapos ito, sige lang, wow, tapos ito naman, wow, ganun naman po.
Hindi na siya equilibrium.
Pero po, they will achieve equilibrium at some point.
Ang concern ko is itong part. 'Di ba? If you nawala. If you use this graph, tapos ito so nag-degrade siya, 'di ba? Hindi pwede by law of mass action or by law of conservation of mass, hindi ka pwedeng makapag-produce ng H2 na mas marami pa compared sa kung gaano siya nagkadami initially.
Pero po, nawala po yung HI eh. So, magka-compensate po siya with the H2 and I2.
Pero HI hindi siya magiging H2 unless may nuclear reaction na nangyari. We are only dealing with chemical reaction, tama?
Where will you get the...
Na-reversible kasi po yung, reversible naman po kasi yung reaction.
Yes, pero take note na in order for you to yung H2 and I2 can only be produced kapag si HI nag-degrade. But always remember na when HI degrade, it always forms both H2 and I2. You can't get H2 from I2. Or vice versa.
You can get both po. You can get H2 and I2 at the same time from HI.
Yes. Kasi kapag nag-degrade si HI, hindi pwedeng H2 lang ang ipoproduce.
Yan po.
Tama?
Same po yung peak. Tapos
No, ang concern ko is yung level nito and yung level nito. Or any other concentration na mas mataas pa sa initial value. Kasi kung nag-start ka let's say with 0.1 sabihin nating mole sa 0.1 mole of H2 or ito na lang yung mismong example natin. If you start with 0.5 mole of H2, yan na yung total amount nung H or nung hydrogen na present sa ano.
Kasi kahit na gaano po how hard the HI tries to decompose.
Yes.
Kasi wala naman pong HI in the beginning. So there cannot be any additional H2 and I to produce. I see the flow.
Yes. Okay, nag-make sense na. Yung reason lang yan is because of the law of conservation of mass. Okay?
When I forgot the law of conservation of mass.
Important yan, wag kalimutan.
It's literally the only law you should never forget.
Yes. Parang yun yung hindi parang hindi mo-violate na klase na. Unless nasa particle physics na rin. Parang wala rin naman.
Opo.
Pero later on you'll see na merong energy and tawag dito, mass energy relationship. So some mass are actually being lost in the form of energy.
With the mass defect.
Yes. So ang tamang term talaga sa kanya is law of conservation of energy. So yung energy talaga ultimately yung conserved.
What do you even call why do you even call it energy po if it can be converted into mass? Shouldn't you just call it mass energy union?
Well, parang ganon. Mas tama siyang relationship. Although syempre, merong certain, kunyari, for this case, ang titignan natin, mass lang. So okay na kahit yung mass properties lang ang tignan natin. For some other aspects, for some other field, ang titignan lang natin energy. So okay lang kung tawagin na lang natin siyang energy. Unless ang pinag-aaralan natin ay relativity ni Einstein.
Oh, no.
Kung saan meron ng mass energy relationship.
When you accidentally forget po E equals mc squared when the plutonium detonates. What am I doing?
Okay. So after filling out the ice table, next is write down the Kc expression.
I'm genius. I found out. What's this? Yes, there's no squared. Wait, it's squared essentially. No! Essentially, it is still squared.
Wait.
Not brackets. This should not be
No,
brackets.
it's always the product over reactant. Okay,
Oh,
product over reactant.
I cannot escape the quadratic equation. I, ang hirap po, hindi po ako makapag-select. I can't undo all of my mistakes. Anyway, I can. Wait, I can't. I can't press Ctrl Z. Oh, yes! Good. Genius.
Something's missing.
Thank. What am I missing? What am I missing? What am I missing? What am I missing? What could I be missing? Two eggs.
Look at the stoichiometry coefficients.
Oh, this should be. Wait, should this be squared? I think this is squared. What? I literally cannot square. I cannot escape the quadratic equation no matter what I do. No matter how hard I try. I am always.
Pero actually, yung resulting quadratic equation dito is easier. Kasi wala ka ng x term. It's just the x squared term and the constant term.
It's a depressed x squared.
Ay, wait lang. Ay, hindi, joke lang. Meron din palang x term. Kasi 0.5 times x times 2.
I am forever trapped.
Meron din pala.
I forgot na there's a basic math and then I forgot that it's supposed to be negative 0.25. I cannot make that mistake again. Ay, mali pa rin. Kahit na ano po. I still cannot escape the... What? Mali pa rin. Patay. Something missing, no? Okay, good. KC is constant. Mali. Naiwan pa rin? Lapin ko nga. Yan. But now, calculus. Technically po, kasi kung at this point, I can just, instead of trying to distribute the bottom part, I will just put this 4x squared sa baba and then I will just invert it. Genius.
For that case, you are free to do any mathematical manipulation for as long as tama siya. Okay lang din yan. Kung saan mas madali sa tingin mo na ma-solve yung value ng x. Okay. Actually, ano rin to, practice din para mas masanay ka kung paano mabilis manipulate yung algebraic equation. Yes, pwede din dyan.
Genius.
So you can just write down 4 over 53 as the coefficient of x squared, no? Or 54.3.
What's 4 over 54.3?
So 0.0 something siya. 0.07.
That's like very hypocritical. Ano po yung I forgot the term. Somehow I forgot what oh my gosh. I forgot. It's you're a hypocrite po if you use the decimal point in the fraction. Because if you're using a decimal point in the fraction, just use the decimal. Okay, good. X squared equals... Ay, mali.
Pero Joshua, if hindi pa siya tapos sa calculation, maybe get 4 to 5 decimal places. Kasi minsan, kapag ni-round off kagad natin, medyo lumalayo yung final
Ako rin
answer.
na round off. Naka-store po
Okay.
sa calculator.
Okay, good.
Plus 0.25. Okay, from the bridge. Now I have to store into X. Okay. Wait. Pwede ba pong gumamit ng X? Oh, nag-store pa rin po yung memory. Good, good. I have learned the fact.
Pero wag ka mag-store sa X. Kasi I'm not sure kung isa-substitute niya ba yung value kapag nag-type ka ng equation.
Nakasubstitute na lang po. Sinubstitute na po yung X.
So baka hindi ko lang sure kung anong ginagawa niya kapag ginamit mo yung solver function.
Yun.
Pero as much as possible, try use the different letters na lang. Yung A, B, C, D, E, F, and Y.
Ang dami po palang mga storage slots eh. I found out yung yung recall function accidentally, and I saw there were too many storage. Okay. How do I pick? I would just substitute anyway.
How do you pick?
Substitute na lang. I have no
Okay.
more choice.
Yun yung best option. Okay?
Ano po, life status, extremely rude. Maganda po, quartic. Gagawin na po yung equation na po, quartic. Tapos ang lahat po yung mga roots positive para check po each and every one.
Hindi na yun makatao.
Ano po yan? Torture na. Where will I substitute it? Oh, I will substitute it in the E. Good, good. But E1.
Actually, between the two numbers, dapat makita mo na kung alin dyan yung tamang answer.
What? Wait. I am severely stressed for some reason. I'm not seeing the snake.
Look at the equilibrium expression for H2 and I2.
Oh, I see. One will become negative. Easy.
Yes. Kasi one of the value of x is greater than 0.5.
I was
Yes,
almost on my way to find myself.
Yes. Okay lang.
Ayun, yes. Good. So, you have, what is being found? Calculate concentration. That's it. All the chemical species involved?
No, use bracket.
Wait. That was, this is the primitive form. This is the primitive way of doing it. I realized. Minus. Huh? I wiped
Kasi yung
away
bracket
the
talaga
memory.
na yan, that's exclusive for equilibrium concentrations.
I have to solve the polynomial again. I'm thankful it's stored in my memory. Nawala, it was wiped away. Store to X. Good. 0.5 minus X. Huh? Yun. They're the same anyway. Why? It looks wrong. Maybe like there. There's no more room. Oh no, where will I put it? Ayun, sakto. Yes. Okay na yan, sakto na. There are like, ngayon, ito pa yung nasaktuan po na, may repeating po na digits at the second and fourth. Ayun.
O ano. Okay, final answer?
Oh no. I'll just check very quickly. Baka may mali. Ayun, final na po. Probably.
Yes, everything is good with the calculation. So these are the correct final answers. Okay, but ano lang all of these are expressed or should be expressed in molarity.
What? Ano po pag minus 5 points?
Kasi concentrations yung hinahanap natin. Okay, question. Do you have any question?
Wala po.
Okay.
Delete storage. Yan.
Okay na to? Pwede ko nang i-delete yung annotation.
Okay na po.
Ayan. What? What's happening? Ayun.
Okay.
Clear. Yes.
Okay. Actually, we have two more example here, but I think I'll just leave these to you as a form of practice exercise.
I will have homework.
Kasi
I will have
for number
I will have homework for the first time.
Kasi for number 10, actually number 10 ano lang te, medyo variation lang ng slight sa question number 9. For this case, all of the reacting species are present initially. Okay?
Oh no. It made it harder. Yes! Lecture na ulit.
Or maybe itong number 11 depende if we will start if we still have time later, pwede nating sagutan yung number 11. Okay? Okay. Pero before that, ito muna. Let's have some discussion regarding what we call the Châtelier's principle. Okay? So, ito na. There are some factors that affect the equilibrium position. Okay? So, the way the equilibrium reacts to that is summarized by what we call the Châtelier's principle. Okay? So, this states that if an external stress is applied to a system at equilibrium, the system adjusts in a way that stress is partially offset at as the system reaches new equilibrium position. Okay, so for this, we will be discussing 1, 2, 3, 4 different stresses involving chemical equilibrium reactions. Okay, so first, let's look at the changes in concentration. What happens to a system at equilibrium if we suddenly change a concentration of any reacting species? Okay, so that means adding or removing reactants of products or products. Okay, for this case, again, remember equilibrium is a closed system. So maybe you find a way to maybe inject some additional reactant dun sa reaction mixture or some other ways. Okay, but this is the basic idea. Okay, if a substance is added to a system at equilibrium, the system reacts to consume that substance. Yun lang naman. Okay, and if a substance is removed from a system at equilibrium, the system reacts to produce that substance. Okay, so look at this graph here. Okay, this is an equilibrium reaction between nitrogen and hydrogen to form ammonia. Okay, so let's say you have a mixture that is already at equilibrium. Okay, so we have a fixed concentration for H2, NH3, and N2. Okay, now at some point in time, you added H2. Okay, more H2 into the system. Okay, what happens is that H2 gets consumed, okay, and as a result, our reaction shifts from left to right. That's sort of the terminology or terminology we use in equilibrium. Okay, the equilibrium shifts from left to right. Bakit? Kasi yung additional H2 will be consumed. Okay, so mako-consume siya. What happens to the new equilibrium concentration of ammonia? It will be higher compared to the initial equilibrium concentration. For N2, it will be lower than the initial equilibrium concentration. Okay? But the whole idea lang dito is that the concentrations will readjust to have a ratio that is equivalent to its equilibrium constant. Okay?
Para po siyang yung tubig pag naano na po siya, undisturbed, ano na po siya, mag-stabilize. Pero pag disturbed na po, it will take another time to restabilize.
Yes, and yung restabilization na yan, it depends on whether you add some more or you reduce the original value per concentration. Okay?
Opo.
Pero yun lang naman yung whole idea. Kapag nagdagdag ka, makukonsume siya. Kapag binawasan mo, it will reform the substance na tinanggal mo from the system. Okay?
Opo.
Okay. Now, additional factor that we looked at is changes in volume and concentration, and pressure. Okay? Actually, for this case, you only have to consider this change if we are talking about gas-phase reactions, or at least reactions involving gases. Kasi if it's purely a liquid or aqueous type of equilibrium, or there are some solid or liquid in the reaction mixture, ang affected lang talaga dito are the gas components. Okay? Because generally speaking, solids and liquids are incompressible. Okay? Or kung i-compress mo man siya, sobrang insignificant na ng change sa volume ng liquid or solid compared sa change ng volume ng gases. Okay? And always remember the volume-pressure relationship. As we increase pressure, this is the external pressure. We are talking about the external pressure here. If we increase the external pressure, you are actually compressing the system. And so the volume will decrease. Okay? Just remember that they are inversely proportional. Okay? So kapag bumaba naman yung external pressure, the system will expand. Tataas naman yung volume. Okay? So for this reaction,
kung may involved po na supercritical fluid, will you treat it as a liquid or as a gas? Kasi compressible naman po sila eh.
Well, actually, for that case, di ba, ang supercritical fluid is neither a liquid nor a gas. It's somewhere in between. Pero I think for compressibility, it has almost the same property as gases. Okay, pero it's a different case than for supercritical fluid eh. Kasi minsan, konting change lang sa pressure and volume, nagbabago na kagad yung characteristic ng substance. Yun yung special with supercritical fluid eh.
Does this mean that they will never ever reach equilibrium?
If they were never ever reach equilibrium. Kung physical equilibrium, do you mean chemical equilibrium? Kung chemical reaction, I think...
Yung parang sa caffeine po, yung magre-react po siya sa caffeine.
I think pwede naman din siya. Okay, pwede pa rin niya ma-reach yung equilibrium, depending na lang kung anong klaseng equilibrium reaction yung tinitingnan natin. Pero yung sa caffeine, you're referring to the supercritical carbon dioxide, di ba? Okay. And I don't think for that case...
Physical lang yata po yun.
And for that case, hindi siya equilibrium process. Yung extraction ng caffeine, it's not an equilibrium process. Ano siya? Actually, pinupush mo yung reaction na mag-favor yung isang side para mas tumaas yung extraction efficiency.
Para umalis po yung caffeine. Ayun.
Yes. Now, look at this example here. So we have the reaction of N2O4 and NO2. Okay? So, actually for the pressure volume changes, ang pinaka-importante lang na tignan mo dito ay yung stoichiometric coefficient ng gaseous components. Okay? So for this reaction, both components are gaseous, pero yung reaction ay 1:2. For every mole of N2O4 that's degrading, it produces 2 moles of NO2. Okay? And the whole idea is ganito lang. Okay? Kapag tumaas yung external pressure, you are compressing the system volume. Okay? So mas masikip yung system. And so the equilibrium will shift to favor the side with less number of moles.
Masarap.
Okay?
Mapipilitan po ay, is it na kailangan po nila mag-conform para mas umuukay po yung sa gas, or is it just because they have more chances of colliding?
Yung collision is actually yun yung start ng reaction, tama? Pero always remember, sa equilibrium, reaction is happening. It's a dynamic process. So whether or not na-compress or decompress, may collision pa rin naman. Actually, ang collision ang na-affect niyan ay rate ng reaction. Okay? Pero yung equilibrium position hindi niya talaga naapektuhan.
Opo.
Okay? So parang ang ano lang dito, yung total pressure talaga na effect. Okay? Kasi kapag nagbago yung external pressure, magbabago din yung pressures ng mga substances. And so magbabago din yung kailangan ding mag-readjust ng pressure ng substances to conform with the Kp value.
Opo.
Okay? So that's the idea. Pero kung i-relate mo siya sa collision is related to the rate of the reaction. Okay, pero reaction is happening in the equation, in the reaction mixture. Nangyayari talaga siya. Okay, at nang sabay yung nangyayari. Ang na-affect lang ng collision ay rate of the reaction and not really the equilibrium position. Okay?
Opo.
Okay. So kabaliktaran naman kung sakaling nag-decrease ang pressure, so nag-expand yung system natin, ang mangyayari mag-shift yung reaction natin to favor the side na mas maraming number of moles. Okay? Kasi always remember, pressure is directly related to concentration. Kapag lumaki yung volume, kailangan din mag-adjust ng reacting species. Okay? So, always double check lang na balance yung equation. And for this part, always just consider the gaseous components. Okay?
Opo.
Now, changes in temperature. For the change in temperature, you have to first know whether the reaction is an endothermic reaction or an exothermic reaction. Okay? So you can tell that if you know the delta H value. Okay? If delta H of the reaction is greater than 0, then the reaction is endothermic. If it's exothermic, then the reaction has a delta H of negative. Okay? Now, consider this reaction here. It is an exothermic process. So, ibig sabihin, delta H is negative. Okay? Tapos, actually, ang technique dito, if it's an exothermic reaction, just think of it that heat is being released. So, think of heat as part of the product.
Opo.
Okay? Tapos, yung temperature change is just, you just have to treat heat as part of the reactant or the product. Tapos yung change in temperature is actually just applying or removing heat.
Opo.
Okay? Tapos pwede mo siyang i-consider kapareho nung ginawa natin sa first stress, yung change in concentration. So applying heat means adding more product. Okay? For an exothermic reaction.
Opo.
Parang ganun lang yung idea. Tingnan mo tong example na to. Actually, dito sa photograph, ito yung reaction na nakasulat dito. Okay?
Is there sort of a middle ground where it's purple?
Most likely. So, kailangan mo hanapin yung tamang temperature. Okay? Most likely. Kasi if you have like an equivalent amount of this tetrachlorocobalt and itong hexaaqua cobalt. So meaning dapat may yung intensity ng blueness and pinkness niya ay almost the same. Na it would look like a violet in color. Okay? Possible yun, possible yun. Okay? Pero for this case, ito yung, this setup has higher temperature. This one is in cold bath, so lower temperature yan. Okay? Notice na this is an exothermic reaction. So if you add heat, you are favoring the reactant side. The reaction will shift from right to left. Tama?
Opo.
For this case, kapag in-increase mo yung temperature, the reaction will shift from right to left. Kaya blue yung color kasi yung predominating species is the tetrachlorocobalt.
Is it possible po to like sort of flash freeze na habang naka-blue po yung solution? Tapos it will take a slower time for it to convert into pink po.
Pero yung independent naman ng ang kinetics ng reaction sa equilibrium. So pwedeng it will take some time before siya ma-convert. Actually may mga equilibrium reaction na na sobrang tagal talaga.
No,
Okay? Like for example, diamond is unstable, tama? And ang gusto niyang equilibrium form niya, ang mas favored na equilibrium form niya is yung graphite carbon.
Opo.
Okay? So naturally, yung diamond degrades into carbon, tama? Pero yung rate yung rate ng reaction niya is sobrang bagal. Na generally, halos hindi natin na-observe. Pero we know from thermodynamics na yun talaga yung preferred direction.
Kumbaga po,
Okay.
parang yung skyscraper, even technically Earth does not want any tall structures. The skyscraper can still last very long.
Yes, pero ibang usapan din kasi ang matter of time. Tama?
Opo.
Okay. So for this case naman, if we lower the temperature, if we put the solution in an ice bath, it will favor the products. The equilibrium will shift from left to right. Kaya yung color niya ay pink kasi mas magpe-predominate si hexa-aqua cobalt ions. Okay?
Opo.
So always remember lang, for an endothermic reaction, put heat as part of the reactant. Okay? For an exothermic reaction, heat is part of the product. Okay? And kung merong increase ng temperature, yung equilibrium will shift. For an endothermic reaction, it will shift from left to right. Tama? Kasi heat should be consumed. If it's an exothermic reaction, the equilibrium will shift from right to left. If you decrease temperature, think of heat as being lost from the system. So the equilibrium has to adjust to form more heat. Okay? So baliktad naman yung magiging shifting ng equilibrium. Clear?
Opo.
Okay. Questions?
Wala po.
Okay. And then lastly, this is the fourth one. Actually, nagkamali lang ako ng numbering. Okay.
Sabi po, niloko si Joshua, questions, violent reactions.
Oo nga, meron ba? Questions, comments, any ba? But anyway, kung wala, then let's go to our number 4. This is number 4, nagkamali lang ng label. So, yung number 4 change or factor, yung addition of catalyst. And ito, this is
Very similar po sa It's very similar po sa yung factors affecting yung rate.
of the reaction. Yes, halos pareho lang din naman yung mga factors na titignan natin. But the important thing here is dapat alam mo kung paano sila nag-a-adjust. Okay?
Opo.
Okay. Now, for the addition of catalyst, it will not affect the equilibrium position. Okay? Walang mafi-favor na product or reactant. Ang mangyari lang, bibilis lang yung reaction. Okay?
Wait, so technically po that was technically not part of it. was just the kinetics.
Kasi hindi siya stress that changes the equilibrium position. But this is part of the discussion just to emphasize that there is no change in the equilibrium position when we add a catalyst. Okay, just for emphasis lang. Okay?
Abo.
Okay. Ito. Let's try to solve this one very quick lang. So for this reaction, N2F4 forming NF2, delta H here is given. Predict the change in the equilibrium. If one factor is the reacting mixture is heated at constant volume, how will the equilibrium position shift?
Fluorohydrazine? Predict the heated at constant volume. So it is not exothermic, it is endothermic. So if you apply heat on the reactant sides essentially, and it's endothermic, it means it wants the heat. So more of it will turn into NF2. So A, possibly. B, some of the NF2 gases released from the equilibrium mixture.
So A, what's your answer for A?
More NF2 po will be formed.
Okay. Or yung common term natin is the equilibrium will shift from left to right.
Apo.
Okay. I'm not sure, pero ganun yung ganun yung terminologies na ginagamit sa libro. Okay.
Chemist after saying products and reactions more than 960 times. Let's just call them.
Kaya ang gusto na lang nila at this point, left to right na lang or right to left.
Abo. Some of the N2F4 gas is removed from the equilibrium mixture. Some of the NF2 will sort of balance out the N2F4 that was just removed. So, yun nga po, so the NF2 will possibly restabilize, but then the N2F4 po will restabilize, but then some of the NF2 was consumed in the process.
So meaning the equilibrium will shift from
right to left. Yes.
Okay, from right to left. Okay? And then finally, letter C.
The pressure on the reacting mixture is decreased. Oh no, this is the problem. Okay. What happens? Okay, so there will be more room for it. Like in the N2O I got inspiration. Yes, because basically po, this is just N2O4. You just replace the O with F. I just realized that. So wait. Technically po, F behaves as H. So does NH2 exist?
NH2?
Abo. Kasi if NF2 exists, F fluorine behaves like hydrogen in some way.
Actually, merong NH2. Pero amide form siya. It's a negatively charged ion.
No.
If you deprotonate ammonia, it's possible. Pero medyo mahirap siyang gawin and hindi siya madaling i-handle sa lab. Pero it exists.
The pressure, genius. So it will shift from left to right because there will be more room than for the NF2 to form.
Okay.
Yes.
Question? Do you have any question?
Wala po.
Okay. Ano to?
Oh no, this is phosgene. Na-recognize ko po eh. COCl. Ayun, sinabi pala in World War I, poisonous gas.
And this is very unstable if you look at the chemical structure.
Ano po, soldiers in World War I somehow driving their cars for some reason straight into the chlorine front lines.
So, sige, let's try to answer this problem. So, the equilibrium concentrations for the reaction between carbon monoxide and molecular chlorine to form carbonyl chloride at 74 degrees Celsius are given. Actually, okay lang. Kaya mo na to. Madali lang to.
Bakit po siya phosgene? Is it because formed po siya by light?
Yung name, actually I'm not sure regarding the name on why was it called
Phos tapos
Phos
na
G.
may gene eh. Phos tapos na generation by phos, which is light. Baka siguro under po light, the carbon
That's-
monoxide and chlorine will mix. Oh no,
I'll try to check.
I have no more room to write. I have to
Di ba kasha?
I have to conserve some of my writing. No, wait, there's already phosgene formed. I have to write that perfect.
Okay, chinek ko yung etymology. They call it phosgene, tama ka. Kasi yung original way to produce phosgene before, they use sunlight sa mixture ng chlorine and carbon monoxide.
What? I was correct? No, that was just a wild guess.
And apparently correct siya.
Yay!
Kasi yung original production niya is by the use of sunlight, using carbon monoxide and chlorine.
Yun nga po, for some reason, soldiers, literally running their exhaust into the chlorine front lines just to produce a toxic gas. Degrees Celsius. Anything. Wait, why am I even computing the ice? What am I doing?
Actually, kaya hindi ganun kailangan ng malaking space.
Bruh! I failed myself. I just realized in the end, when I was about to write the data, maganda po yung gagawin niyo po, parang may tapos in the end pala, nakasulat po, ito lang po yung hinahanap, hindi yung iba. So, sinulat po lahat, yun sa final po na makikita niyo po.
Pero for that case, I think it's wise to read the question carefully first. Lalo kapag sobrang haba, tapos parang feeling mo, ang dami namang sinabi, hindi naman pala kailangan itong mga ibang
Yun
given.
nga po,
Mga ganun.
yung nga po sa Olympiad problem, may parang eulogy po eh.
Yes. Actually, before, di ba, meron kaming intercollegiate na quiz bee na sinasalihan.
Opo.
Meron doon mga question na sobrang haba ng question, and then pag tinignan mo, nandun lang sa last 2 sentence yung kailangan.
Bro.
Minsan nagsabi pa ng background tungkol sa substance na sinasabi, pero di yung kailangan to solve the problem.
Lalo na pagkamadali po no?
Gagawin na po.
Ganyan.
Ito po yung eh.
Mas sa med po ganun eh. Sasabi ko sa nila parang trick question na lang.
May nga po eh.
Yes, sir.
May test po eh. Tapos at the very end po, sinabi po, calculate only this.
Yes. Parang lang yun, dahil madali lang yung question, dadaanin ka na lang nila sa i-overwhelm ka na lang nila sa pagkaka-state ng question.
Yun nga po is the evil part.
Sa med nga, sa amin nga po, kunyari madali, ang daming negative. Kunyari,
Nakata to the negative too.
Ganun nila, parang logic na lang. Kasi ang dali ng topic.
Yes, sir. Mga ganon.
Ayaw ka nilang maka-perfect eh.
Inarin po ako, I was tricked din. Po ako, it turns out, in the end, it was just 0.012. Nothing should be missing. Yung zero ko po parang may ganun po sa ulo eh. May parang bolt. Calculate.
Meron akong na-notice.
Okay. Which one? Oh no, what is wrong? M. 1.2. 1.2.14. The equilibrium concentrations. So,
Is the reaction balanced?
yes, I think.
Yes, it is balanced, okay?
I used this one. This is evil. This is evil. I really hate that one. Lagi ko po nagawa po yun. I always raise it to the subscript if it's literally not necessary.
Okay. Remember, you only need to raise it to the stoichiometry coefficients, okay?
That was evil. Yes, the KC is within reach. Calculate KP. Huh? I forgot what this was. KC R. Yung R po yung 0.082 po. Yung 0.8257.
Yes.
0.082057. And then times.
KP is in terms of atmosphere, KC is in terms of molar concentration, so R value should be 0.08257.
I saw it. It's the degree Celsius. I can no longer be tricked. Kelvin. There's nothing changed. Oh, this was just to the zero. Evil. Why?
Wait, zero ba? Wait, hindi siya zero.
Wala pong na-change sa... wait. Meron pala na-change.
May nag-change. May nag-change naman.
Meron naman po akong panglaban po dyan. Undo. Hindi na po ako maano dyan. Hindi na po ako natatablan. Yun na accidentally natanggal. Back in business. Nawala! Fortunately, there's a constant. Wait, mali pala yung constant sa calculator. 0.082. Yes! It's also within reach. It's very relieving pag yung the KP and KC are not like 10 to the 148. Yes! Completely successful. Why is this? Bigla na po kumbaga po, may nadaanan po mahirap, tapos bigla na at yung pinakahuli po, yun yung pinakamadali.
Actually, for this, this is just an additional exercise to recall what we have covered on the first topic. Okay?
Abo.
Now, sorry, excuse me. Biglang sabakit yung mata.
Ala, yun na po. Nasakta.
Okay. Okay, so ayun lang, be careful with how you look at the reaction, okay? First, make sure that the reaction
Betraying po talaga yung mata ko po.
Okay, make sure that the reaction is balanced, and then when you write your equilibrium constant expression, always make sure that each equilibrium concentration are raised to the respective stoichiometric coefficient. Okay? And this is also correct. Kp is just equal to Kc times Rt raised to delta N. Okay? And since all the reactants and the products here are gaseous components, so they take part in the delta N calculation. Okay?
Dapat po
So these are correct.
gagawin niyo po yung ano niyo po, yung stoichiometric equation po. Parang may mga numbers. Para kala po ng estudyante, balance na kasi may mga numbers na po eh. Pero hindi na po alam. It was not.
Pero actually kung sa class, mas prefer ko na yung mas straightforward. Just to check na nasusundan yung concept. Pero be careful kasi kapag dating sa contest, lalo kapag mga quiz B, sobrang dami nilang mga tricky questions. Kaya minsan makaparanoid ka, balance my equation.
Hindi, dapat yung pinakamaganda po dyan, kala na po hindi balance. So, chinek na lahat. Gagawin na po, bibigyan na po siya maraming i-check, pero balance na pala hindi yan.
Diba? Naglagay ka na ng mga maglalagay ka ng medyo sketchy na Pwede na maglagay ka ng sketchy na mga stoichiometric coefficient.
Pero tama naman pala po in the end. Naubos yung oras. I'm clear. Ayun, cleared. Dami palang mga additional exercises. Oh no, dami kong
Yes. Actually, titignan ko kung alin dito yung mas challenging.
binigay sa akin yung pinaka-challenging. No. Medyo kaya pala. Sorry. Akala ko po na mali pala yung ano.
Eto. Let's do question number 3. Okay. So, iano ko lang din muna. So let's do question number 3. So a mixture of 0.47 mole of H2 gas and 3.59 mole of HCl is heated to 2,800 degrees Celsius. Calculate the equilibrium partial pressure of H2, Cl2, and HCl if the total pressure is 2.0 atmosphere. So for the reaction, H2 plus Cl2 forming 2HCl, Kp is 193 at 2,800 degrees Celsius.
Diba? Nagalaw. Wait. Nagalaw. Parang nataiyan yung part niyan. Ayan. Yung nakainis po dito, nagagalaw po yung video, pero ito pong yung parang ano po ng pagsulat, hindi po nagagalaw sa baba. Mixture. Huh? Wala? This is so sick. Do I need the ice?
So for this problem, the only initial components are H2 and HCl. Okay? And yung total pressure dito, that is 2 atmosphere, this is a constant total pressure. Okay? By the way din pala, Joshua, kapag sa ice table, if you use Kc, kailangan nang i-fill in mo sa table ay molar concentrations. If you use Kp, kailangan nang ilagay mo ay partial pressures in atmosphere.
May idea po ako dito. I will get Kc and then convert into Kp and then find the others. Oh no, this is like
That will also work, but it will depend on the given.
Mathematics. Liters, where's the liters? There's no liters.
So kaya yun, you can convert KP to KC, pero it will still depend on the given. Okay?
Literally. There is no liters. I've been tricked. I've been fooled. Aha! Genius. I will use the PVNRD. Or is this legal? Volume must be the same. I'll just get the average if they're different. Wait, why did I even write the PV equals NRT? Destroy. One. What? Why did I write 1? It's supposed to be H. I'll just write R. Degrees Celsius.
3.59 is not for H2,
For HCl.
Then I will just rename it to HCl. Genius. When you get in, whenever you face a problem po in life, just rename things. P. 2 ATM. Wait, this is the partial pressure. Oh, the total pressure. It's not just the HCl, this is everything. I should calculate everything. Wait, is this legal? What am I doing?
Okay, before you proceed,
Partial volume.
comment. What will you get if you substitute the number of moles here? Anong value yung makukuha mo? What volume is that?
The partial volume po kumaga ng HCl.
But do you need that? How will you use it?
Wait, what? I just realized the same thing. How will I use it? I will find the molarity of each of the H2 and HCl.
Pero yung molarity is the number of moles divided by the total volume of the reaction mixture, right?
Yun nga po. So I will add those partial volumes to get the full volume and then divide everything. Divide each of the reactants ko by the total volume.
Yeah, I think that can also work. Pero if for this case, maybe you, instead of calculating the volume, maybe you might want to calculate the partial pressures instead.
How will I calculate the partial pressures po when I literally have no volume? Oh wait.
How do you calculate for partial pressure? You are given the number of moles, tama? And remember, for this mixture, it only contains initially H2 and HCl. There is no there is no Cl2. Okay? If the total pressure of the system is 2.0 atmosphere, given that these are the initial number of moles, how do you calculate for the initial partial pressure?
Mhm. Mhm. Mhm.
Remember mole fraction?
There's mole fraction? Ah, yung ano po, yung mole x something. XA. Ah... mole... Naku, mole fraction nilang P... X... Ano sa kabila pala sila ng equation? Oh no. Wait, I'm doing Raoult's law pala. What am I doing? I forgot. Nagagawa ko pa pala yung Raoult's law.
How do you solve for the partial pressure given the mole fraction and the total pressure?
Mole fraction times...
Diba, the idea lang is if you have a mixture, yung portion na ino-occupy depending on the number of moles is relative to its mole fraction, ay to its partial pressure. What P is this?
Total.
Total pressure. Diba, the total pressure times the mole fraction will give you the partial pressure. Okay?
It's like a workaround po of the ideal gas law.
Yes.
Yes, so I don't have to calculate anything else. Good. Inaiwasan po yung having to find the partial volume. 3 3.69 over 3.69 plus 1.7 times two minus. Haha, genius. Instead of doing all of that hassle. 5, 2, 7, parang so.
Can you check the labels again?
Oh, I'm still wrong? Oh, I did the opposite way again. How could I possibly do that? That's like, that's so inhuman. That's inhuman. That's inhuman. I did it twice in a row. Anyway, life moves on. Easy. I don't have to do everything again, unlike others. Calculate the partial pressure if the action is 183. AP equals back to algebra. Whatever 1.768473. I wrote it the other way.
May kulang pa na step before you can proceed with
Oh,
that.
almost. Na-square po siya for no reason. Ah, wait.
No, I
Square
mean,
pala
may
talaga.
kulang pa na step before you can proceed with that. So far, what you have calculated are partial pressures. And these are partial pressures under what condition? Is it the initial? Is this already the equilibrium partial pressures?
These are the original ones. Ah, so
So
this is
initial.
QP. This is
Okay.
not QP.
So kung initial yan, you still have to track the change in the pressure as the system reaches equilibrium. Tama?
I still have to use the diagram po pala po. I deleted it. No. I always forget the things I need and then I always put the things I don't need. Okay, so there are 2 dots. Weird. Shoot. Ah, tanggal din isa.
Sorry.
Kala ko po in that exact moment, I thought everything blew away. Wait, this not ICE. Oh, it's initial, but then it's in pressures.
So as I mentioned kanina, for the ice table, you can only list down concentrations in molarity or pressures in atmosphere. Yun lang. Okay?
Yes!
Kapag
Pwede
pressure,
Posible naman pala po.
pero kapag pressure kasi usually minsan binibigay in torr or in millimeters mercury. Be careful not to directly substitute them in the ice table value.
Ako po meron na po akong battle scars po doon eh. Baga hindi ko po na-convert.
Pero you have to work on that. Kasi tama yung calculations eh. Pero minsan you have to be careful with the units, okay, with the balance, whether the equation is balanced. Okay.
C. The change. Where's the change? There's no change.
For CL, what is this? What does this mean?
It somehow increased.
No, I mean, when you put the question mark here, what do you mean by this?
Zero pa pala po yun. I didn't mean that. I almost forgot. Why is there a very tiny dot po? Hindi ko po matanggal. I'll just draw on it. Haha. Okay, easy fix. C. Oh, it should go the other way.
Yes.
It wouldn't make sense.
Actually, sure tayo na ang direction ng reaction. And rin pala, don't write full arrows. When dealing with equilibrium reactions, never write full arrows. You always yung equilibrium arrows.
And mukha pa rin pangit somehow.
Although sure tayo na according to the initial condition, the only way that the reaction can proceed to equilibrium is for the reaction to proceed from what to what?
From HCl to H2.
To H2NCl2. Okay.
What's the change? Oh, this positive.
Actually, lang, I don't know, it's a matter of convention lang. If you write the reaction as that, you can simply write minus X sa reactant side plus X plus 2X sa product side. Pero later on, you'll know that the X value that you should get is a negative value. Tama.
Mm.
Pero ano lang yan, it's just a matter of convention. If you write it as plus x sa reactant minus 2x sa product, okay lang din. Kasi ang important pa rin naman yan is yung final na equilibrium concentrations na mga calculated.
What? I still have to... There... Ayan na po ako. Meron po... talagang... the quadratic equation cannot leave me. It can't leave me alone. There's always a 2 or a 3. Why does this have to be done to me? I figured it's a constant. Anyway, I'll just leave it as PHCL. I'll just transfer in the calculator. $193 na lang. Hindi naman desay. Mali. Hihi. 193. Wala naman. Wala pang mistake, wala pa. Okay. Shift solve. Easy. What? Why did I write that? It looks like it looks. I still did not change the eraser. X equals. I really have to solve it. Oh, the only way it can continue is if x is negative. But what if both of them are negative?
Isang value lang nakuha mo, no?
This is so stressful. I hate it.
Pero actually, you don't have to worry. Kapag yung nakuha mong value ng x is nag-fit siya dun sa value, most likely yung other value hindi. Ganun lang yun.
Hindi dapat gawin na po yung ano po yung gagawin na po work backwards. Gagawin na po make both values seem reasonable and then work backwards. Ultimate ano po, ultimate test. This probably won't fit. The current pressure is like that. It's too negligible. This probably isn't it. I still have to solve in the end. You know what? I will just I don't like this anymore. I will make this completely exact up to the final decimal the calculator says. 2 times No, I saved it into the memory. I did not. I rounded off. Good. 0 to m. 2 times 57.47 plus 3.89 blah 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 GIGN 0 9 3 6. That's very unfair. Wait, something must be wrong. Ah, nothing. Nothing's wrong. I'll just put this. Lagay ko lang ATM sa taas. I can put ATM anymore. Okay, it's game time. Tanan tanan tan tan tanan. Ah. It's
Parang
like
nakuha mo na yung value ng x, di ba?
nakuha ko po isang value lang that doesn't seem to fit.
No, actually pareho tayong nakuha. Pero tinry mo ba siyang substitute?
Please tell me pero kung tama naman po siya, the calculator is so so it's for some reason the calculator knows my moves. It's probably watching me.
Pero can you write down again the value of x that you get earlier?
Apo, plus 2x. Now I have paid myself to write every single digit, even though it's not real necessary.
Okay, now if that's the value of x, what will be the equilibrium concentrations, pressures of H2, Cl2, and HCl?
This will be ito pa yung ultimate na torture po if this is not the correct answer. I can't put it above. I'll just put it here. Ah, genius. Instead of writing meticulously, I will just type it in. Test. Ah, good. Save to x. Haha. pH 2.2315270.936 minus x 0.282 38426. Hee. Haha! I can no longer be extra.
So for H2 so far, we get an acceptable value.
But then.
For Cl2, definitely it's an acceptable value kasi you just multiply it to -1.
Please tell me this won't be wrong. If this is wrong, I will just this is the one of the few times I will be forced to die.
Actually, it looks okay. Kasi x, yung
I
twice ng x.
I the wrong place. I deleted everything. Okay, ayun, undo.
May undo naman.
Aha, may undo. Wait, I should have just moved that to the other panel. You know what? I'll just move it to the other panel. Okay, I'll just copy. Wait, I have to type it anyway. Bro, it's already on the calculator. 419.
O nawala yung ayun.
Wait up po. Yee! Woo! Talagang inexacto ko po yung placement ng para yun. Okay, CL2. How do I calculate CL2? I'll just, oh wait, CL2 is
CL2 is,
negative x.
that's just negative x. So you'll just make the value positive, okay?
Okay, I better not, and I better not put it in the wrong place. Because after that, I cannot erase it anymore. Everything correct? Okay, good. Where's the something? There. Final answer, I think. Wait. Calculate the equilibrium partial pressure. Okay, good. ATM. All in ATM. All in ATM. Because I had no room. I can't highlight this. I have to do it manually. Ah, no! Haha. Easy. Final answer.
Okay, final answer? Okay.
Expected na po yun. I need to check if it's
Okay.
completely
No,
correct.
actually, these are correct values.
Yeah.
Okay. So for the equilibrium partial pressures, or actually for this kind of problem, you are given the starting number of moles and the total pressure. From there, you can calculate the partial pressures. And since you use the initial number of moles, the value you get are the initial partial pressures. Okay. And then by constructing the ice table, you should be able to get an equilibrium expression relating the equilibrium pressures. Okay? And solving for the x value, we get this one. And then by substituting, we get this equilibrium partial pressures in atmospheric units. Okay?
Ano po yung calculator po na? It knows, it is watching my every move. It lives in my walls.
Pero when you do the solver function, yung shift solve, ano yan? Usually yung binibigay niya is yung pinakamalapit sa mas preferred niya kung yung isa ay may imaginary part, ibibigay niya yung wala. Or between positive and negative, usually mas ibibigay niya ang una yung positive value. Okay?
Opo.
So these are correct. Okay?
Yes!
Question? Any question?
Violent reactions.
Meron ba? Meron bang violent reaction?
Meron po. 0.01 nanonewtons.
Okay. So far, okay? Everything clear? Okay. Actually, we still have some other examples here, but maybe we can leave this for now. And iwan ko siya as part of additional practice exercises kapag natapos natin yung topic. But we're already done with the chemical equilibrium part 1. Okay, this is just the part 1 of chemical equilibrium.
Kumbaga po, ganun na, kumbaga po, parang yung linak po kayo sa tapos nakalabas po kayo, pero yun, na-realize na po, you're just in a big cell. Kumbaga, nakatakas po kayo sa Alcatraz, yung mismong prison po, pero yun pala nasa island na pala siya.
So meron pang additional obstacles. Pero I will send another set of slide kasi yung next part natin on chemical equilibrium will be dealing aqueous solutions. Okay? So far what we covered are equilibrium reactions involving gas-phase reactions.
Ito ba po yung sinasabi na pong isang ibong topic na aqueous lang?
Yes.
No!
So yun yung next topic natin. Okay? And we'll start that on our meeting next Tuesday. Okay?
Sir.
Okay. So, questions? If wala nang question, then I will end our discussion here.
Ang question na lang po, pagka nasa Japan na po kayo po, matuturuan niyo po si Joshua.
Yes, kung ganitong schedule, I think available pa rin naman po ako.
Thank you very much, sir. Thank you very much po. Thank you.
And parang yata po na, parang one hour na lang yata po yung difference.
1
Kasi-
hour lang naman po yung difference.
May ano po yung sa South Korea po, sinasabi na po 1 hour lang from the Philippines.
Ano lang, ahead lang si Japan ng 1 hour. So,
Apo.
currently, almost 10 o'clock sa kanila ngayon.
Okay po.
Apo.
Ayun po.
Thank you
And
po.
yun, that's it for today.
Apo.
Thank you so much.
Thank you
And
po.
see you next Tuesday.
Okay po, have a
Okay.
nice
Thank you po.
sir, have a nice
Thank you
weekend.
po.
Okay, I'll send the slide na lang maybe this weekend siguro.
Okay po.
Sige po. Thank you, thank you.
Thank you
Sir,
po.
happy weekend.
Happy weekend
Happy
po.
weekend din po. Bye-bye.
Bye-bye po. Among Us.